All right, so what we're supposed to do is write the formula for the derivative of the function that's given. All right, so this one we have s of t equals negative 36.9. Well, what do we know about negative 36.9? Now, well, that's a constant, and so that means s prime of t is going to be 0. We didn't have to do anything. We knew that if we took a derivative of a constant function, we get 0. What about the next one? Well, v prime of t, well, e to the 0.05, the opposite of that, well, this is just a constant as well, and it's just going to be down on the negative region. And so really, that is going to be 0 too. Now, if we had an x in here or something else, or a t rather, in this case, then things would be different. But since this is all just numbers, then that's a constant, and so the derivative is just 0. Well, what about this one, f prime of x? Well, this one we can use our nice power rule, and we can go bring the 4 down. Then we have x, 4 minus 1, that's 3. And we have our derivative. Again, directly. We didn't have to do any other work as far as point and close point algebraically or plug in, and find limits from the left and from the right. We just directly did it with what we have. Okay, what about this one? Well, now let's think about this instead of maybe as ln of 2. What if this was y squared? Well, that's going to give us basically m prime of y is going to be 2y to the first. So we took our 2 down in front and we took 2 minus 1, and that's how we did it. Well, it's going to work the same way here. We have m prime of y is going to be, well, that's just a number, so we're going to bring it down front, ln of 2, and then we have times, and then we have y to the ln of 2 minus 1. Okay, so we have that then times this. Now that's ln of 2 minus 1. That 2 minus 1 is not together. We have actually, the ln of 2 and then minus 1 if we need to think about it that way. So that would be the key on that one. Okay, and again, we have to think about what is that? Well, that's just a number. ln of 2 is a number. And so then we bring it down front and then we subtract 1 off of it. All right, so the next one we have, our first time we have a negative exponent. So what do we do with negative exponents? Well, g prime of x is we bring it down front just like normal, negative 6, then we have x, and if we need to, we can write it out, negative 6 minus 1, and so that's a minus 6 x to the minus 7, and that would be then g prime of x. All right, what about this one? Well, here we have h prime of x is going to be equal to, well, now we're going to bring the 3 down in front, so it's going to be 3 times 2/3 x to the, now we're going to take 3 minus 1, and that's going to be 2. Well, what's this? Well, that 3 cancels that 3, and we just get 2x squared, and then that would be our h prime of x. Okay. Sometimes, it's not always going to be nice where it cancels, and so you'd have 3 times 2 over whatever, maybe that was a 17 or something, and you couldn't reduce it. So you could have something like that. Okay. But this one, it was nice. The 3's cancel. Just have 2x squared when we get done. All right, what about these? Well, again, we're just going to bring that down, and now this time g prime of x is equal to. Now remember, that's a constant times something, so we can take that constant and leave it out front, so 3.2, and times, now we're going to bring our 3 down, and then it's going to be x, subtract 1, squared. Now this is another one where we have a minus 6.1 times. Now we bring down the 1, and then x to the 1 minus 1. And again, I'm just going to kind of write this out just so you can see. Now what is this? Well, this is a constant, so this is, minus 0. Okay, so the derivative of a constant is 0. And so now what do we have? Well, we have a negative, and have 3 times that, so it's going to be a negative 9.6 x squared. Here, x to the 1 minus 1 is x to the 0. X to the 0 is just 1, so now we have just minus 6.1. And then that would be our derivative, okay? And then we have that 0 on the end, but it's 0 as well, so it's nothing. And so that is the derivative of that trinomial. What about this one? Well, this one I think I'm going to rewrite. I'm going to say, well, that's really negative 2.1 x to the negative 3. So sometimes you have to write it in a different form to make it easier to work with. And so now I'm going to have t prime of x is equal to, well, I have my negative 2.1 out in front because that's my constant. I can bring that out in front. That's c. And then I'm going to say, okay, well, now I have a negative 3, then x, and now I'm going to have a minus 3, minus 1, so that's going to be a minus 4. And so that gives me 2.1 times 3, so that's going to be a positive. Negative times negative is positive. 3 times that's going to be 6.3, and that's going to be x to the negative 4. Or if we want to write it in the same kind of format, we can have 6.3 over x to the 4. So it kind of depends on this one if you want to have it all on one line or if you want to go ahead and have the fraction. All right, what about this one? Well, this one again, I think I'm going to rewrite as exponents only. So that gives me 11x to the third minus 8x. Now the square root, remember, is to the 1/2. Okay, so now I have something that I can do kind of like I did up here or even here. And so I have h prime of x is equal to, well, now I have 11 times 3x squared minus 8 times, now I have 1/2 x. 1/2 minus 1 is minus 1/2. Okay, so now simplifying, I have 11 times 3, so that's 33x squared. Well, half of 8 is 4, so minus 4. And then I have x to the minus 1/2. Now again, with this one, I could rewrite this as 33x squared minus 4 over square root of x, and that would be just fine as well. I could have that, or I could, leave it as the negative 1/2, or, there I could put it over x to the 1/2. It kind of depends on how you want to look at it, on what you want to do there. But that's, I think, what I would do as far as, my final value there. I would have the 4 over that radical 2, and that should be good as far as your final answer. All right, so let's go on to the next one here, and that's going to be 4x squared plus 19x plus 6 over our x. Now, so what are we going to do with that? Well, on that one, I think what I'm going to do is I'm going to break it apart, because this is that divided by that plus that divided by that plus that divided by that. So I could really write that 4x squared over x plus 19x over x plus 6 over x. Now, can I simplify that? Yeah. Well, that x cancels one of those, so that gives me 4x plus, now those x's cancel, so I have 19, and then plus, now here I have an x in the denominator, nothing in the numerator, so I'm going to take that up there, and that's going to be 6x to the negative 1. Now I can take the derivative of that very easily, comparison to that one anyway. So then I get k prime of x is equal to, well, here's a 1, so bring down the 1. It's going to be 4 times 1, so it's just going to be 4. The x goes away. And then this is going to be plus 0, because that's a constant, so the derivative of a constant is 0. And then plus, well, now I have 6 times. Now I'm going to bring that negative 1 down in front, so it's a negative 1. X. Now minus 1 is going to be to the minus 2. And so if I simplify, that's going to be 4. And then 6 times minus 1 is minus 6. X to the minus 2. Or, as we've been doing, 4 minus 6 over x squared. Okay. And so again, which one of these is more correct? It really doesn't matter. I think, you could have it either way, and you're going to have basically the same answer. So I don't care which way you do it for the class. This is probably a correct one if you don't want negative exponents. This would be a correct one if you don't want to have fractions in your answer. All right, so that's all I have for that part. Let's come back in a little bit.